Hey everyone, I am Said and welcome back. Today we're gonna go through 3 very common integral problems involving natural logs. These are classic exam questions, so pay close attention. Before we start, if you enjoyed this video, please hit the subscribe button and don't forget to leave a like. Let's dive in. Number 1, if the integral of 1 plus e to the 2x over e to the x dx equals f of x e to the x plus c, then what is f of x? First, simplify the integrand, means split the fraction. So we have the integral of 1 over e to the x plus e to the 2x over e to the x dx equals the integral of 1 over e to the x equals e to the negative x dx plus the integral of e to the 2x over e to the x. If we using exponent rules, we have e to the 2x minus x. So we have e to the x dx, right? As you know, the integral of e to the ax plus b dx equals 1 over a, means the derivative of ax plus b times e to the ax plus b. So here a equals negative 1. So the integral of e to the negative x equals negative e to the negative x plus the integral of e to the x equals e to the x plus c equals f of x times e to the x plus c equals f of x e to the x plus c, right? So we have e to the negative e to the negative x plus e to the x equals f of x times e to the x. If we divide both sides by e to the x, we have negative e to the negative x over e to the x plus e to the x over e to the x equals f of x, right? So final answer equals f of x equals negative e to the negative x over e to the x, means e to the negative x using exponent rules. So we have e to the negative 2x plus e to the x over e to the x equals 1. So f of x equals negative e to the negative 2x plus 1. Number 2, evaluate the integral of ln of the square root of x over x dx. First, rewrite the logarithm. We know that ln of the square root of x equals ln of x to the power of 1/2. So we have equals 1/2 times ln of x. According to the power rule for logarithms, we can pull that exponent to the front. So ln of the square root of x equals 1/2 ln of x. Let's rewrite the integral now. The integral of 1/2 ln of x over x dx. Look closely, we have ln of x and also we have its derivative 1 over x. This is perfect setup for u substitution. Let's u equals ln of x. So if we take the derivative of both sides, we have du equals dx over x. So we have 1 over 2, the integral of ln of x equals u. u times dx over x equals du. So 1/2 times, if we use the power rule, we have 1 over 2 u to the power of 2 or u squared plus c. So we have 1 over 4 u squared plus c. u is ln of x. So final answer equals 1 over 4 ln of x squared plus c. Number 3, evaluate the integral of dx over x, the square root of ln of x. First, choose a substitution. Because we see ln of x inside the square root, the natural substitution is u equals ln of x. So if we take the derivative of both sides, we have du equals dx over x. This is perfect because dx over x appears in the integral. So the integral becomes the integral of dx over x equals du, and u equals ln of x, so 1 over the square root of u. So we have the integral of 1 over the square root of u equals u to the power of negative 1/2 du, right? If we use the power rule, we have 1 over negative 1/2 plus 1 u to the power of negative 1/2 plus 1 plus c, right? So we have negative 1/2 plus 1 equals 1/2. So 1 over 1/2 equals 2 times u to the power of negative 1/2 plus 1 equals 1/2, right? Or 2 the square root of u. U equals ln of x, so if we substitute back, we have 2 the square root of ln of x plus c.